So thank you for coming. My name is Kostadin. I'm team lead in cloud technology in the simulation algorithm development area. And I'd like to give, I have gave this talk before, not in front of this audience. It's possible that you have heard about it because it was given at JPrime last year and also a few other conferences here in Bulgaria. Yeah. In case you have any questions, you're welcome to interrupt and clarify something on the slides, unless we're going to talk for this a few slides later, then I'm going to postpone it. And there will be time for questions after. Can everybody hear me well? Everybody is on the back seat in the back. Yeah. The back row is filled. In the front there is only 3 people. So, okay. I'm also involved in the Java user group events, so JPrime is one of these. And JPrime is approaching, so I hope that I'll see some of you there. It's awesome conference, and I'm sure a lot of you have already been there. About me, I'm using Java for many years, since Java 3, I think, was the first time when I started doing it. I obviously have strong interest in test automation, unit testing, software design, and the connection between these. So I love to write and share my experiences and talk also at conferences. I used to update the blog that you see here more often, but now I'm speaking more, making presentations, but I also put them there. So you can check even the slides, not the last version, but a version of the slides that you're going to see here are going to be there in case you want to check it out. Check them out. All right. So I know the name of the presentation is a little vague. It doesn't tell really how exactly what are we going to do. And I'd like to start with a question, so just to give you an idea, a question, which is how do you programmers, because I think most of people here spend their time programming professionally. How do you think programmers spend their time? What do you usually do in a day? Do you know about a study or actually that measured what are you doing when you sit in front of the computer, and what are you actually doing? Are you writing code? Are you reading code? Are you debugging? Are you writing some specific kinds of code, maybe front end or tests, or are you trying to understand what's going on? So Microsoft actually did this study for the first time more than 15 years ago. Why do they need to do it? They were deciding that they were actually developing Visual Studio at the time. And this was time before social media. So what they got as a result is that the average programmer on average project will spend by average 5% of their time actually writing new code, 25% changing existing code, and 70% reading, debugging, all kind of activities that could be grouped together in understanding code. And yeah, if this is done today, probably going to be like 20% social media or more. Yeah, but yeah. So is this real? Can we verify this? I'd like to give like an experiment, a thought experiment we can run here in the room to verify it, which is very simple. So how can you imagine an ideal programming day for you? So does anybody want to take a guess? Like what's an ideal programming day?
To deal with integration testing.
Okay, that's why don't you want to deal with integration tests? What's the problem?
Usually in our cases developing is like 20% of the time. The rest of the time goes to meetings and unit testing.
So meetings are a problem. So interruptions. So people usually answer something in that direction. So a good example will be, so we go in an isolated place, no interruptions, a hut in the woods or in the mountains. And you go there for 8 hours, you have internet connection, you have everything, so you have absolute focus, you know what you have to do, you do it, you code for 8 hours, and then you're finished. So this is the absolutely ideal programming day for many people. Maybe not for the people here, but many, many people, I guess, you can relate. So imagine then what happens if lightning strikes and after 8 hours you have just finished, you close your laptop. You have just finished, lightning strikes, and your laptop is fried. You just lost your work. Thankfully, you have a second laptop. So you have a second laptop with you, and you just open it. There is a dev environment. You can start coding immediately, and you just finish the task. So you actually remember very well what you have just done. How long do you think you're going to replicate the same amount of work, the work that you have just finished and lost?
2 hours.
2 hours.
20 minutes.
20 minutes. Yeah.
Based on the diagram, 5% coding, no thinking.
Yeah. So like just writing. Yeah. So okay. And second, how many of these days do you actually get ideal ones? How many of those did you get in the last month? 0 in this year? 0 to 1? Okay.
None.
0 to none, okay? So you don't get a lot of these. So the net result of one ideal day of coding could be summed in 20 minutes or 2 hours or 30 minutes or whatever. So the question is, what were we doing in the other 7+ hours, which is something different? Like what were you doing? So, and this leads to this quote, which is by Kristen Niggard, who is one of the creators he's the co-creator of the object-oriented programming, which is that to program is to understand. So this is what you do most of the time as programmers. Yeah, that as well. But the issue is that this is not what we want to do. What we want to do, I actually run a survey with people I know over Twitter, etc. Like 50 people responded, so I don't know if it's very statistically, like it's a really good statistics. But anyway, I asked them, actually, what do you want to do? Do you want to understand existing code, change existing code, or write? So what do you enjoy the most? 75% said, I want to write new code. That's what I enjoy the most. But what we actually do is something different, right? We spend 70% of the time doing this part, and 5% of the time doing this part. So yeah, this could be a problem. So what can we do about this? Can we actually reduce this 70%? And for different projects, these 70% could be more or less. For example, if you start on a greenfield project, everybody wants to start on a greenfield project, right? So there is not much code left. Everything's kind of, we know where you're going. Everybody wants to go. Everybody's excited to go on these projects. You don't want to go on a legacy projects with 2 million lines of code base, where you know that you're not going to write a lot of new code. You're going to find the places where you can place your new code for most of the time. So, okay. So can we make this real? Is it possible? Sorry, I duplicated the slide. Can we somehow automate part of it? And where would you optimize? Of course, where it's actually the biggest part of the pie chart. So the problem is that we have understanding, which we spent most of the time, but understanding are really not easy to execute. Hard to share, very hard to scale. Like, can you scale what's inside your brain? You have to tell it to somebody. So it's not easy. So how can you call a concrete, small, executable, verifiable, and scalable understanding? And I call it a test. Yeah. So at least that's my own definition, but I think it's a logical one. And if you can understand, if you can automate even small part of this pie chart, even 10% of this, if you improve it, then you double your time actually producing what you love most, or writing new code. So a test is understanding of the system. So a test could understand the system, so you don't have to understand the system. And you can even verify it. What a test is not is understanding of your system implementation, or should not be, because that's like double work. And for all this to work, we actually have to trust your test. Actually, does not matter at all. Nothing matters if you do it. So the question is how you can actually do this. Is this possible? And I'd like to give you a few examples, very concrete examples, how you can actually do it. It's nothing breathtaking, just some good practices you can do. So this is a test. Don't try to read it. I know it's small. So every test has a name and has arrange, act, assert parts. Or some people like to say the given when then. So that's like every possible test. Can imagine follows similar structure. Okay, and where can we actually improve the tests and inject a little more, make it more readable, inject some understanding? There are a few places I put on the slide, and we can start with the name. So first, test registration is an okay name. It's better than test 1, test 2, test A, test B, test error, case 2. Still, registration with mandatory fields is successful. It's a common pattern that you can see in many Java projects right now, and not only in Java. And what this means is what we test underscore when condition does that. Yeah. Some people believe this is against Java coding standards, because in Java coding standards you usually have short names, etc. But you're going to call this method ever? No, it's called by your JUnit or whatever by reflection, so he actually doesn't care if it's a short or a long name. So you can put as much information there as you want. Like registration with Facebook is successful, or registration with missing email will return an error. So just put a little, it's much better than registration fails. Yeah. Or even you can do this. For your users, test registration with mandatory fields and actually have an actual emoji there. You can do this with some frameworks. You can do this, for example, with JUnit 5. There is a notation there you can put on the top of your test called display name. You can put anything there. You can put emoji support even. So you can put emojis in your test name. This is how you do it. Yeah. It's making everything much more readable and understandable. This is how it looks when you actually execute it. You can actually even go and do these tree-like structures, which is another feature that we're going to actually has other benefits, not just readability, much bigger benefits. We're going to show this a little later. Also on the JVM, frameworks that can actually do this if you're using Spock for Groovy, Spec for Kotlin, Scala, Test for Scala, they also have similar features. For example, this is Spec for Kotlin. It's very similar with if you're testing JavaScript, probably have used Jasmine or Mocha, or if you're familiar with Ruby, RSpec. All these frameworks are using the so-called describe it pattern, when you just describe something, describe users, and you put an it and you just type English or whatever language you want to type. So, here. Okay, this was names. What about the other part, the last part of it, which is the assertion part? Have you seen this assertion before? So that's JUnit 4 assertion. It says assertion failed error. So your test fails, you open it, and you see it's an assertion failed error. It doesn't actually tell you anything about what actually failed. This is if you try to write assert true. I guess many people know, write JUnit here, so know about assert. So if you put assert true and inside the condition it's false, this is what you're going to get with JUnit 4. With JUnit 5, they changed it. At least they said, okay, it was supposed to be true, but now it's false. Isn't this better? Just to actually have the actual message, registration should be successful. And you can still do it with JUnit, even the version 4. And this is how you do it. You can add an additional parameter at the beginning, which is the message that you're going to get after you execute it if it fails. If you're already migrated to JUnit 5, which is live for more than a year, they actually changed and put this parameter last. So yeah. Yeah, it's very useful. So try to use it. So that was assertion. And the next part is the arrange part, or the given part of the test. And what I frequently see in a lot of test code will be you construct something, like a big objects. Maybe they came from JSON or from somewhere else, who knows. And yeah, you look at them and you actually don't understand what's this null, what's the first null. Then we have an email, that's obvious. Then we have names. Okay, probably this is a middle name. Maybe it is, maybe it's not. There is some gibberish here. Who knows what this is? Then there is another null, there is another null, and then there is 5.0. So actually you have no idea what these fields, you just read them, do you have an idea what these are? Yeah. Yeah. What about this? There is some mocking happening here, and we are calling some class called users repo. Okay. Create user, it returns 5. Is it the same 5 as this 5? We don't know. Is it the same 5 as the 5 on the previous side? Probably no, but could be. So one way to fix this is to extract a variable or a constant field and just give the name. So you now know this is the user ID. So without looking at what create user method does, you just know it returned the user ID. So you don't have to actually go there and dig it. You can plainly see it. And then you know it's the same thing. So just looking at the value, it's impossible to get this information. And what about our user request? Like you can just replace the nulls or whatever with the actual names, which will be null authorization token. So the first null was authorization token. Then mail, names, password hash. Okay, this was the gibberish. No phone, no address, and the last thing is something called sign up bonus. And even wasn't the name of the test actually registered with mandatory parameters? So why we are actually even constructing something that has parameters that are not mandatory? So maybe we should actually make a constructor that includes only those. It's possible, or extract a method. Just anything that will just remove all this noise and make you focus, because your tests will fail a lot, and you have to change them a lot, and it will interrupt you, and you want to spend as less time on this as possible, because yeah, you're not writing tests just because you write tests. You're writing them because then you execute them a lot. Okay. Other noise you can remove is, like a common error I see is not wrapping. It's possible to actually wrap an object and just use assert objects, not object internals. So assert true, result is successful, assert equals user ID is the result user ID. You can just make it one line. Okay. Another thing you can remove is everything that is, let's say, let's test this just in case. Which I have wrote a test, let's test this thing that the test is actually supposed to test, but let's test all these other things just in case I may need them, or I don't know. So those are also irrelevant information. Try to assert one thing in one test. It's not always possible, but at least we should aim for this. And if you assert different things in the same test, maybe it's an issue that you have another test that you can extract from this one, so you can have two. And yeah, no more, let's be on a safe side and test everything. So yeah, the point was I made earlier is, yeah, tests are going to fail. So try to make them easier for people to actually read and understand. So suppose we do make the tests more easier to read. So let's try that. Given this, we have saved some time. We have saved like 7% of our time. So understanding now it's only 63% of what we do. This will double the time, more than double actually the time we are spending writing new code. But is it free? It's not free, right? It's not free. That's the problem. More tests means more code, so it's more code to maintain. So, which brings to a second point, which is that a test should be testing the system behavior, not the system, not your system implementation. There is always going to be like a tension. There is always going to be like coupling between your code, test code, and production code. This is inevitable, but still it should be. Okay. There is a question.
I have a question. What I like to do, because our project is quite big and it's a bit monolith, it's been known since 2009, I believe. So
10 years.
There is a lot of code there, and because the tests are slowing down the development times, I mean build times, mainly what I aim to do is just implement the user's request. I mean, if you have Jira to implement some new feature or change this feature, what I do is just make this the business requirement, make it into a unit test and forget about it. What I think, and next time I go back, if I have forgotten what the feature does, I will get the idea because I have my feature and business requirements written as unit tests. Is this a nice approach, or it's going to explode in the long run? I mean.
Well, it depends. So I cannot repeat the question. It was very long, but in a way, as I understand, I'm repeating because we are also recording. Sorry. So when you are actually like having something like an executable specification of your business requirements, that's what you're actually doing. And is it like a high-level test or a low-level test?
Unit test. It's
a unit test. So what is the unit then? What is the unit in your case?
The unit is
a class, a component, the whole working monolith.
On class level, of course.
On class.
And on method level, but as far as it gets, I mean, it might contain several methods inside. I mean, the test might test several things. But in the end, it tells you when you do something, when you do this case, this business case, this will be the result.
Okay, so if this is what you have actually done, then great. That's the aim. You have actually reduced your time. Yeah. So okay. So the best place to understand your production code is your production code. You go there and you look at the implementation. You don't have to actually go and check the test code to do it. And the problem is that if you have actually tested your implementation, then when you change the implementation and your tests fail, and the behavior actually stays the same, so it's a wasted effort. What does a test need to know then? Where is the coupling? What should we know? What should the test know about the production code? It's okay to know the dependencies of the class, if it's a unit test for a method. It's okay to know the dependencies of the class. It's okay to know what the method returns, what are the parameters. But everything inside, everything here, it's like a danger zone. And if your test knows a lot about the internals of the methods that you test, you're going to have like a change detector test, which is a problem. So let's look what are we actually taking. Just an example. This is some kind of register method. It takes a user request. It returns user request result. It goes into a user repository, creates a user, returns user ID, wrapped in some kind of object. That's all it does. So let's try to follow the implementation part, the execution part, and see what we actually have to do. So first, suppose we actually have construct the user request that we want to do, then we have to use some kind of mock. We don't want to use suppose we don't want to use actually the user's repository create user method directly. We want to have like a fake object and say, okay, when it's called with this user request, return me some user ID. Then we call the method that we want to test, we get some result. Then we say, okay, did we call actually the user's repository or with the correct parameters? Okay, we check that. Then we construct what we expect to get as a result, and we assert is expected the same as actual. So this is if you actually follow your implementation path. But there was one mistake here. Did you notice the mistake? Anybody?
Check for the repository methods.
Yeah. Why do you actually need to check this? Is there going to be, if you delete it, is there going to be a difference or no? So it's amazing how many people actually just write tests like this, and the main issue is people usually write the test after the implementation, after the code.
But if you don't have this line, then it's not guaranteed that it's created in the database. At all, this method could not be called in your implementation.
Is it actually guaranteed that? So, because actually, if you don't see the first line up there, if you actually do not call user's repo with this user request, it will not return the user ID. To return something different. So if you call it with null or another user request with different parameters, so not something equals to exactly this, it will return 0 or no. And if it returns no, what you expect is not going to be the actual thing, and your test assertion will fail.
But yeah, again, you know that in your method you call the create user. If you don't know this is part of the implementation, that in your method
Sure, yeah.
create user.
Yeah.
This is thing you know, but if this line is not in your method, you mock something, then it's not code and some random data is returned. I mean, you should know some part of your implementation.
Yeah, but you should not write a lot of code about it. See, this is a common mistake. So the rule is mock commands, stop queries. So it's kind of unfortunate that in the Java world, people use mock for like almost everything. It used to have that Mockito or other libraries, they have a stop actually concept, but it was completely replaced by mock. So stop is something that is replacing a method, for example. And mock is something that is replacing, but you can also verify that it actually got called. So if you are having a query, what does the query mean? Okay, if you have a command. Okay, command is a method that doesn't return anything. So if it doesn't return anything, you actually have to do it. We need this code if it's calling something external. If it's a query, if it returns something, then this is not needed. It's okay to just stay with the initial. So this you stop. Yeah, when user's repo, then return user ID, that's all. But if it was not returning, if the method was not returning anything, if it was like a command method, then you don't need to do this. Also, try writing the test first. Many people don't like test-driven development, but if you actually, the benefit is if you actually try to write the test and think about it before, if you have no implementation, you have less implementation details in your test. So it's a win. Yeah. Also prevents the let's test this and that and that and that. It happens quite a lot. Yeah. So of course, implementation, dependency, and your intention, your code is always going to be like somewhere in the middle. So it's impossible actually to isolate everything. It's not possible. So can we ease the pain? I want to show you two examples of how you can do this using common features of favorite and yeah, just JUnit and other libraries. So suppose we are changing our code and we add another parameter to a method. So we have user exists and we just want to add a check not by email but also for phone. So we do the change, we prepare a merge request or whatever we do, and we see that we changed just 2 lines of production code, and we had to actually change 9 lines of test code, which is something that's weird and we don't want. And okay, we had to change users repo. We made a change in a class called users repo. We have changes in users repo test. Okay, that's understandable. Why are the most of our changes in other classes? So can we take a look in the users test, for example? So we take a look, and we find there is some test there. And what we see in those tests, there is like one part that is common between those. And this part. This is the case when user does not exist. So we take a look at the code now. And we see, yeah, these are the tests. They have like, this is the common part that's actually the same. And what I'm trying to tell you is that your test cases are often a tree, and you're trying to put them in a list because in your test classes, usually you think a class and there is a list of methods there. It's not a tree, but your test cases are actually a tree. When your user does not exist, it's like a branch of, it's like a branch that you go inside in this tree-like structure. How can you actually create this kind of tree-like structure? The best way right now on the JVM, which is and easiest to use for me, it's the nested feature in the JUnit 5. So how does it look? We have already showed the slide before at the beginning of the presentation. So this is what you get in the end. So you just extract this, and this is what IDEA will give you if you run the test. What you do is you just create another class, a subclass, and put it in your test class, and you put the nested annotation on top of it. That's all. And what now you can do is you can extract the common, each class can have a setup, and they are going to be executed one after another. So first it's the one for the test, then is the one for the whole test, then is one that is going to be for the subclass. So you can have like an incremental setup. And this means that all common setup can go in one place. And when you do this, you remove actually a lot of duplication, because previously you actually had the same thing duplicated in 3 methods, and now you have only one place. So you can actually do this even with a common method you extract. You don't actually need a special feature in a framework, but this is much more easier and convenient to use. And also your tests are much simpler. Every test now will be like 4 lines of code instead of 6. So you have saved some space. You can do this with JUnit as well, 4, with the 4.12. Actually, I think there is going to be 4.13 now. I think they put 4.13, so this is slightly incorrect. But if you actually do this and make the same change again, the same change we started, and you change the user exists method and make the same thing, if the tests were written like a nested structure, then suddenly you save some time. You now had to change just 5 lines of test code. It was 9 before. So easier to maintain, also easier to write new tests. So there are a lot of benefits. Okay, we kind of solved the problem with users tests. What about here? What about users repo tests? Can we make this easy as well? Maybe, maybe not. So if the code that you want to actually check everything is okay, is a pure functional, like an email validation is a very good example, then it's actually pretty easy to do that. Those are 5 emails, 2 are okay, 3 are invalid. The red ones are obviously invalid. So this is a simple test, which is a valid email is valid. So you have some kind of method that's called class email validation. There is an isValid method, and you put the email as a parameter and you return true or false. So these are two lines of code. And then you have a similar one which will be, it's not valid. So if you put the invalid one, yeah, so you have like 4, 5 tests. What you actually needed was maybe some kind of method that will, given an email, will be actually, do you expect this to be valid or not valid? So if we had this, it was going to be easy to write many tests for different cases. You can create individual tests and just put one line that will call mail validation. You can use JUnit 4, for example, which is pretty easy to set up. Not really. If you do this with a lot of notations, or run with specialized parameterized runner, then some parameterized parameters, then you say, okay, we are going to extract the first parameter email from this structure, and then the second is going to be expected another from this structure, and you do this, and then you can actually use it in the method, the method that we wanted. So it's a little, let's say, not very easy and convenient, but you can do it. Also, if you want to have a separate test for the valid ones and the invalid ones, you have to create another class, which is not very easy. In JUnit 5, this is what you need to do. If you want to have only the valid emails, for example, you just, there is a new feature called parameterized test, and you just put different sources. This is value sources strings, and you put the strings, and it will assert all those are okay. You can now add the additional test cases just by placing more lines here with another emails. You can have another test that is for the invalid ones as well. And there are many other ways to actually provide parameters. You can check the JUnit documentation for this. More than. Actually, don't know how many of them. There is a lot of them. Yeah. Like, for example, here is enums. Yeah, you can say run this test for all enum values except OK, because they are all invalid, and check that I return an error. This is something that, for example, I like to use a lot when I'm testing, I don't know, REST API or something. Yeah. Of course, this means a lot of annotations. If you're not a big fan of annotations, you want to make a bit more functional way, you can go to Spec, for example, or Groovy, with Spock for Groovy, which essentially is just declare a list, and for each of those describe a test. So this is the relevant part. So you make a list. This is a Kotlin method, and for each of those, you get the email, describe a test, and check it is valid. So yeah, Kotlin is nice. Of course, if you're writing Java, maybe you don't want to introduce Kotlin just for the needs of testing. But there are many projects that actually introduced Spock, so Groovy, for that purpose. So maybe there is a valid user case for that. So suppose we use parameterized test. Did we solve the problem? If we actually make a use of parameterized test somehow for the user's repository test, then yeah, we can actually now make the change, and we will change just 3 lines of test code. So this is an improvement. So these are powerful features that not many people use. Nested and parameterized tests, so means less code that is much easier to maintain. And personally, I like them. They lead to much faster development. So try to, if you like them, then try them. All right, and the last point is how to make actually test trusted. You have all probably know about the test pyramid. Like say, all models are wrong, some are useful. what the test pyramid actually tells you, at least how I understand it, is the higher you go, it's often easier to write tests. You write less of those, but when they break, you actually don't know where the problem is. And you have a lot of smaller ones, which are very, very focused, but they break a lot when you change your implementation. So smaller tests are smaller problems, just like children. I happen to have 2 children, small ones. And when they were babies, it was easy. So I had to change diapers a lot, but changing a diaper is not a big deal. And now they are bigger, and we have to choose a school, which is a big decision, but you actually don't have to do a lot of those. So we have bigger children, bigger problems, but less of them. You have probably seen this picture. Of course, you cannot just go with small level tests always, because you end up situations like this. So you cannot go only with unit tests. You need also the higher level. So you need the whole pyramid. It's possible that the pyramid is not looking like pyramid for your project. Like I said, all models are wrong, but this one can be useful. So the higher you go in the pyramid, the harder to know where the problem is when it breaks. So like a rule that I have tried to follow is, when one of my end-to-end tests fails, I'll try to make the unit or as low or level possible test to actually reproduce the problem. So I know that it will catch the problem when it happens again. It's just a rule that I like to follow, and it really helps reducing maintenance in the long run. Yeah, so this is approaching the end of the presentation, so just let's wrap it up. So automate your understanding, not automate your implementation details, and automate at the lowest possible level. So that's it. If you have any other questions, you can ask them, and you can get the slides from this link if you like them. No more questions.
Yeah, all right.
We had some questions before, so okay. Okay.
Thank you.
So thank you.